This is a talk about Ansible, so unfortunately there's going to be a lot of YAML involved. The entire talk, all the slides, everything that went into it, all the playbooks I'm going to run, and the demo at the very end is all hosted in this GitHub repository. You can check it out. You can actually run these plays later with Container Lab, which everyone here is going to learn how to use later today. I did get some feedback from the steering committee when I put in my draft slides. They looked at the number in the bottom right and they said, Brandon, that's 63 slides. You only have 30 minutes. Are you sure this is going to work out? And I said, guys, don't worry about it. Jeremy was talking about the speed of light this morning, and I got to tell you, it's got nothing on me when it comes to presentation speed. So this is kind of going to be a story about my journey learning how to configure networks with Ansible Network Resource Modules. So in support of that, this story, and we're going to tell a little bit of a story. So imagine that you are walking into a brownfield network. It's been deployed for quite some time. There's no automated configuration management. It's been managed by a team of network engineers logging into the CLI and running commands for quite a few number of years. It's multiple vendors because procurement departments love to do that to you. And management stated that, well, we understand we can't manage the entire config across our entire fleet today. We'd like to start taking baby steps in the right direction to do partial configuration control. Do things like set NTP servers or SNMP configuration. And we want to be able to confirm when engineers change that and configuration gets out of drift. Furthermore, the server team's already using Ansible, has a lot of experience with it, and has talked to you about how it's easy to teach engineers how to use Ansible instead of trying to teach them how to learn something complex like a programming language. So you put on your Ansible hat and you step in with your first step. Is number one, never test in production. So this is the inventory that I'm playing with today with Ansible. It's two routers, one an Arista EOS running on Container Lab, and then an IOL iOS on Linux also running in a VM in Container Lab. So our first playbook looks pretty straightforward. We're going to start simple and then iterate. So we just have one play where we want to set some NTP servers on our test device. So we write a one task play. We just run the iOS commands Ansible module, tell it to just enter some NTP servers. And we run that on our laptop against our iOS device, and we get some green OKs back. So that works great. But there's a couple of problems with this first approach. Number one, we're not getting any feedback from Ansible on whether or not we changed anything on the device. We don't get any information on idempotency. Number two, what if we have to change NTP servers sometime in the future? We're only dealing with adds in our current play, and we can't handle any changes or removals at all. So we go back to our playbook, and we'll take another try at it. Let's dig a little bit deeper. Let's do a multi-task play where we manually collect the configuration from a device and parse it using TextFSM. We use Ansible filters to determine what we need to add and remove. And then finally, we'll use a Jinja2 template to actually push the changes to the device. So this play is a little bit longer, but it's still pretty easy to follow. We run the CLI parse command to actually parse out the config against the template. We use the difference filter to figure out our sets of add and delete. And then finally, a Jinja2 template to render and push the config. Those templates are really straightforward. Like, all we're doing is collecting IPs and then adding and deleting. So we run that on our laptop, and it works great. Now we're getting feedback on our changes. We can see that one device did get a change this time. But there are still a few problems with this approach. Number one, we haven't even tried running it on our Arista device yet, and when we do, we get an error on a failure saying it can't actually work for this particular vendor. Furthermore, this might be a simple change where we're adding and removing NTP servers, but what if you have something more complex? What if you add authentication to your NTP configuration? What do your templates look like then? What if you're trying to do something like route maps on a device? This is actual Jinja and Ansible code checked into a repository at IMC today attempting to solve that problem. And it's so complex, it scrolls off the slide. So the problem here is that Ansible, Jinja, FSM, etc., they're all domain-specific languages. They're very good at doing a very narrow focus and doing it very well. So let's take the complexity and put it into a general-purpose programming language. And the general-purpose programming language that Ansible is written in is Python. Now, I hear what you're saying. I said at the beginning, we wanted to go with Ansible because we want to make it accessible for engineers and make it easy to do. But now we're talking about writing a bunch of code, doing configuration modeling in that code, having to write CLI parsers for all your vendors, and we haven't even talked about using REST or RPC with Juniper or iOS XR. And all of this works in Ansible? Well, you don't have to worry because the Red Hat Ansible team already wrote all the code. So let's talk about Ansible Network Resource Modules. They're a set of vendor-specific Galaxy collections written and supported by the Red Hat Ansible Network team with full documentation. They provide the networking framework that allows Ansible to talk to various vendors and devices via either CLI, HTTP API, RESTconf, etc. And they all handle device fact collection natively and do configuration section management. Furthermore, they support check mode execution so you can do dry runs of your plays prior to running them. Unfortunately, they do not support diffs today, but they do provide some feedback in the results of the module's execution. So let's rewrite our play to configure NTP servers using an Ansible Network Resource Module. This one, Cisco.ios iOS NTP Global, is designed to run on iOS devices. So now we take the intention, or what we want on the device, and pass it in as a config dictionary. And we'll print out the return value of this Ansible, or this play. So we get immediate feedback. The device has changed, and it provides us with information on exactly what we did and what commands were ran. And if we run it again, we see that absolutely nothing has changed, and reports it as such. So we do have idempotency. So let's open the hood just a little bit on this so we get a better idea of what's going on. Ansible Network Modules are an ARG spec that covering the model of the configuration section on the device. You can think of this as what you want on your network. They also have a fax module that handles populating the have ARG spec. It goes out, collects the configuration from your device, and populates it into the same model. And then finally, there's the config module that compares the want and the have and actually generates what needs to happen on the device to make your intentions reality. So let's dig into the first two of those. So the ARG spec, the arguments that you actually pass into the module when you're executing it. The first one is the state directory. It controls the actual module behavior, what you're trying to do on the device. We'll go into that a little bit later. And then second, a config dictionary that contains the model for this specific module. In our case, our example, we're doing NTP_global. The config dictionary and the specification for it is similar between OS and collections, but not identical. And we'll come back to that at the end of the talk. The ARG spec for every module is extremely well documented with extensive examples. So going through the first two, the states and the config, the states, there are 4 primary ones and then 2 that are mostly just useful for debugging, and I'm going to go through all of them for you. So the first state is merged. It is usually the safest state. It will try to never remove anything from the device it doesn't have to. It will add to existing config and keep what is already present in there. It can even do this on individual ACL entries. So if you have an ACL that has sequence 10, 20, and 30, and you have a module that's trying to merge in 15 and 20 as part of an individual play, it'll add 15 and replace 20. So moving on, we have replaced. This replaces a subsection, usually, of the configs on the device. So if we're talking about an ACL, it will allow you to replace just a single ACL. If you're talking about NTP, it is actually going to replace your entire NTP config. Really highly recommend, again, reading the extensive documentation and examples and performing testing when doing plays with replaced or overridden. The overridden state is when you say, I might have something on the box, but I really want only what I'm telling you to be on there for this section. It will replace the entire section of the config that it manages. If you do overridden with a single ACL, it's going to delete every ACL not in your config module. So as usual, test whenever possible. The fourth state, deleted. Do I have any guesses as to what this one might do? It's pretty straightforward. It removes the section from the device completely. You should use this one with care. The last 2 states are useful when debugging. There is the gathered state. What it does is it goes out to your device, collects config, and prints out what the config module would be that would generate that config for you. Then there's the rendered state. It's an inversion of gathered. It takes your config, whatever the config dictionary you pass in, and actually renders the commands needed to produce that state on your desired device. So repeating, the ARG spec is extremely well documented. There's examples for every state in every module. They're similar but not identical config specs between vendors, and you should test a lot. In the GitHub lab, there's a playbooks/states play that actually runs through all the states, all the states on the iOS ACL module and their outputs. So the second part of a network resource module is about facts. If you've done any work with Ansible, like early on in the life of managing network devices with Ansible, you probably see gather facts false near the start of every play. And the reason that this used to be was Ansible was written as a server management language, and generally speaking, what it did was it tried to collect facts about the server you were running it on. Well, if I'm trying to collect facts on a Cisco iOS device and it's just telling me what's on my laptop, that's not very useful for me. So resource modules actually include facts modules for every specific vendor. So it uses the connection that you're using to determine which one to run appropriately. So instead of gather facts false, it depends if you want to run it or not. So as I stated, each device vendor has a specific fact module. You can call them individually as a task, as you can see in this example here. I call the iOS facts module as a task. Because it is a fact interface that has some of the same options. You do gather subset, and you can pass in the Ansible standard list of subsets to only collect specific information about a device. Each Ansible network resource module, like NTP Global in this case, also has a gather network resources argument. So we can collect the configuration and so we can collect the config model from the device and present it as a fact in the Ansible plate. So if we run this play and we dump a bunch of information from it, we can see that we went out, we collected the facts, and we connected to an iOS device. We can see all the facts that were gathered by looking at the keys list inside the Ansible facts. And then finally, when we look inside network resources, which is where it stores the configurations of the resource modules that it collects, we can see that it collected NTP Global as well. So gather facts is a play level keyword. Like if you are defining a play, you can just say gather facts true or false at the top. Gather subset is also a play level keyword. Gather network resources is not. If you try and put this at the top of your play, Ansible will complain and say you can't run this. However, gather facts, when you run it at the play level, it's really just a hidden task that calls Ansible built-in gather facts. So you can tell Ansible module defaults at the play level and have it pass in network resources, gather network resources for you, and then just turn gathering facts back on for your play. And we'll have the same result as the task that I listed earlier. So we talked a little bit about the complexity and where all that has gone into the resource module. We don't have to worry about the modeling, the config collection, or the command generation. We still haven't really shown how this works for multiple different OSs. How is this agnostic? How can I run it on an EOS device, or an XR device, or a Juniper device? All my examples so far, I've been showing the actual fully qualified domain name of the module specific to a vendor, in this case, cisco.ios.ntp_global. And I pass in my state argument and my config argument directly to that task. There is also a wrapper task in the netcommon collection, so ansible.netcommon.network_resource. This is a wrapper that handles figuring out the correct collection for the specific device in your inventory using the Ansible Network OS variable. And then you just pass in the name of the resource that you want to configure on this device, the state and the config dictionary as you would normally. So if we update our previous play to use this model and use that wrapper instead, now we can see that when we've run this for the third time, well, our iOS device has not changed. The Arista device is able to be configured and is now changeable. That works great. But remember back when I said that it was similar between OS collections and the config modules, but not quite identical? Well, if you dig down into this on this specific example, if you're trying to set the source interface for your NTP configuration, well, if you're working on an Arista device, that's local_interface in the config. And if you're working on iOS, that's NTP_global in the config. This just blew my mind when I found it, and I actually opened an issue with Ansible, trying to say, can we do a little bit more work on trying to do normalization of the config dictionary between vendors so we don't have to worry so much about that? Lowest common denominator is usually best when dealing with things like that. However, since we have to deal with what we have, not what we want, there are a couple of approaches for dealing with this issue. Well, we could just run individual tasks for the different OSs and pass in the different variables to the module as we call them. So in this example, we would run one just for iOS with the correct local underscore interface, and then another with Arista with the source and the interface that we want it to be on. And we would use a when statement looking at the network OS to determine which of these two tasks to actually execute in your play. This works, but it does generate a lot of extra task output in your code because there will be skipped tasks for every OS that you're trying to do a module on that no change is taking place. Another approach, and one that I recommend and that we're looking at doing a lot more of, is to use host-level variables generated via your inventory to generate the correct configuration for your specific module. So in this case, when we're defining our host in our inventory for EOS, we would pass in a dictionary containing the configuration that we want to pass into the resource module itself. So we have an NTP underscore config variable that contains our config. And then later, when we're running the actual task itself and executing the module, we just use Ansible's Jinja replacement at the task level to pass in that dictionary to the module. So I'm trying to think, this can be difficult for some people to take. So we've defined a variable in the inventory, and then we're using it in the play. So while most people use host variables just for single string replacement, you can do entire dictionaries, lists, and the like in host variables. And you can use your inventory management, either if you're using, you can either do a YAML in a file and manage that via GitHub, or if you have a more complex inventory plugin via tools such as Netbox or similar. Anything you can think of, as long as you generate the correct configuration and pass it into the inventory, you can run it as a module. One note on interoperability that I do want to highlight is that resource modules commit, but they do not save. So if your device differentiates between a running config and a startup config, that's on you. I've opened an issue on this with Ansible, haven't heard anything back. It does seem like that would be something you would want as an option in most of the modules. But for now, you can use handlers and listen events in order to detect when there is a change and you're not running in check mode. Just go ahead and save that device. And of course, it's slightly different for an EOS device because the CLI command is not supported in HTTP API, another bug that I have open with them. So we've talked about all the things needed to run the modules. I've done an example of a lot of different plays, and now I've got about a 3-minute demo kind of showing running through a set of resource modules for those two devices in my lab. And we're going to see if the internet works here. Nope. We are going to run the demo. I'm not good at Mac, sorry. Okay. So this is me on my laptop. Like I said, once you learn Container Lab, you can develop stuff like this locally anywhere you are. And so the first thing I'm going to do is quickly deploy my lab, the two devices that I talked about. Through the magic of video editing, this minute-long process takes only about 5 seconds. So I'll log into the EOS device very quick, just to show we really don't have any configuration on here. There's no NTP servers defined, no real IPs other than the management IP. Looking at our demo playbook, so like we do, we're going to gather the facts that we want so we can see the config dictionaries and print those out in our debug task. The system MRM network resource module is a special case, so it has to be run independently. But we are going to actually configure a lot of stuff in this single task using a loop. So I'll talk about this a little bit more on the next page. If we take a look at our inventory, you can see that we have a config dictionary that defines the states that we want for all of the network resource modules that we're going to execute in this play. Down here, we have a nm-configs dictionary that contains the configurations for the modules. This is the intent, what we want on the device. So we already talked about NTP, but hey, let's configure an interface, throw some IPs on this device, and configure BGP. And we also have the same down there for the iOS device as well. So when we run this playbook against our inventory in check mode, we can run through. We see it gathers, connects to both devices, gathers facts, tells us that it would be making changes. It loops through every single module that we have configured in our configuration dictionaries, says that there will be changes. And if we scroll up, we can see the facts that we collected say that we don't really have any configuration on the device itself. And we can confirm that it was ran in check mode. We go in, we check the NTP and the IPs again. Nothing has changed on the device. We remove the check mode. We go through. We're going to see much of the same output. As it goes through and actually logs in and changes the config of the device, and finally ends up by running our handlers, which will save the startup config for us. One for each device. So we can see that a change was made, and we log in. Now when we look at the NTP associations, we can see the servers that we want are configured. We see that the interfaces have IPs on them, and we already have a BGP neighborship with our iOS device, which was configured to match. And we already have routes. And again, when we run the play one more time, so the exact same play, it takes just as long. And this time we get OKs back instead of change because we aren't making a change on these devices. And if we go look at the facts that we collected as part of our fact collection, we see the configuration dictionaries that are also present on the device. And that is the end of that video. Let me see if I can get back to my slides. B1, I can't find it. Yep, there it is. So again, all of this is in the repository. You guys are encouraged to take a look at it, run this yourselves. Get Container Lab up and running later today. If there's any questions, I'm happy to take those now. You can open issues in the repository, find me at the social, but thank you so much. Sure. The question was any Juniper, and the answer is I do not have a support contract with Juniper. It does work, but I'm not able to show it to you in the demo. So I don't have an image I can run like in Container Lab, but there is a Juniper repository managed by Ansible, and it will log in and configure devices via the XML RPC interface, if I remember correctly. Yes, again, since this is all extremely well documented, if you just Google Ansible Network Resource Module and Juniper, it will take you to the Ansible collection, which is all the modules that it supports, and it will show you exactly what configuration sections it will support as well.
Thank you.
I'll repeat it too.
You mentioned that you can point Ansible to Netbox. So in your example where you had the different syntax for the Cisco and the Juniper, how does that work with Netbox? Like you have similar flat files in it?
Trying to find that slide. I personally don't use Netbox. We have a homegrown inventory system, so I can't comment directly on that. I don't have enough experience using that inventory plugin. I apologize.
How does the Ansible react if the device asks for a prompt? Like, say, for example, I want to remove usernames or delete users on a Cisco iOS XE. It asks for confirm. How does that work there?
So it's handled inside the Python because, again, it's a bunch of Python code that is handling handling all of those specific things. So there is things built into Ansible already that look for specific prompts and reply with answers. And that's in Ansible. So they have the code in Python already to respond to system prompts when they are coming up in the configuration.
So, okay. So that's something I have tried and it doesn't work in there. So I have to open up.
You'd have to open a bug. Yep.
Yep. Okay. Thanks.
All right, let's give it up for Brandon. Thank you so much. I appreciate it.